6.5 Summit is back for its sixth year, and we are talking AI nonstop. We're building out those hyperscaler data centers all the way to the endpoints and pretty much everything in between. We have had Jim Anderson on the 6.5 multiple times, multiple companies. This is wonderful, and I'd like to bring him in. He's now CEO of Coherent, and we're going to talk about cloud infrastructure and talk about photons and how they're enabling all of this AI goodness. Jim, great to see you.
Great to see you too, Pat. We love photons and happy to talk about photons all day long. So thanks for having me. I appreciate it.
Yeah, absolutely. I like to call it, Jim's playbook, right? You come into a company, you run the play, modify, make tweaks, and I've observed it and really enjoyed watching it at three companies. And you did the same thing at Coherent. And at least from an investor point of view, it's all about talking to that audience, but you also have to bring in things like core value proposition with your customers, where the market is headed there. But I think the first thing probably in people's minds is, first of all, who is Coherent? Why do photons matter to AI?
Yeah, absolutely. So first of all, Coherent, the simple way you can think about the company is it's really the global leader in photonics. And what is photonics? Just to make sure everybody knows what photonics is. So photonics is really about harnessing the power of a photon, and the photon is the basic particle of light, harnessing that power of that photon to do all sorts of amazing things for our customers. But the three basic things that we can do with a photon is we can transmit data with it at very high speed, at high bandwidth. We can use photons in, for instance, lasers to change the nature of materials. And then the other thing we can do with a photon is we can bounce it off a surface and we can measure or sense things about the nature of the surface. So that's the basic things that we can do with photons. But all of those basic things drive an amazing amount of innovation. And in data centers, AI data centers, photonics and the photon is becoming an increasingly important part of data center architecture and how data centers are getting designed and built. And Coherent's really at the center of that.
Yeah, it is amazing. Even though it took a while for photonics to become a reality, the growth curve is astonishing, and it's directly related to the need to move a lot more data quickly and also do it at lower cost due to power and maybe a simplified infrastructure. It's been pretty astonishing, and I'm not in the copper will die camp. We keep giving life to copper here, even creating new protocols for it to talk over. But it's great to see. It's great to see how this industry has migrated. Go ahead, Jim.
Yeah, I was just going to say, one of the things about photonics is, I started my career in the world of electrons, right? I've been in the semiconductor industry for almost my entire career. Actually, I started as a microprocessor architect on data center servers, right? Way back when. So I've been around data centers my entire career, mostly in the world of electrons. But photons have some pretty amazing properties relative to an electron, relative to the power efficiency and the bandwidth of data that they can transmit. And so what we've seen over the course of data center evolution is, Pat, you'll remember when we first started building data centers, all of the networking connections between the computing nodes were all electrical when we first built data centers, right? And now, if you fast forward to today, the entire scale out part of the AI data center, which is all the connections between the racks, that's all optical today. Because as we increase data rate or we increase distance, you're kind of forced to move out of the electrical domain into the photonic domain. It's really the only way to achieve the bandwidth that you need. And so now today, AI data centers, entire scale out portion of the network is optical. And what we're going to see over the rest of this decade is the beginning of the last remaining part of the network within the data center that's electrical, which is the scale up. These are the connections within the rack. those will start to migrate to the more use of optical in the scale up portion of the network as well. So again, photonics and that technology just continues to become more and more important to how data centers are architected and designed.
Yeah, optical went from I can't afford it to you can't afford not to do it,
Yeah, that's exactly right. That's well
right?
said. Yeah.
Yeah.
Well,
So, hey, let's talk about differentiation. Every company I talk to says they're the leader in AI, and they're driving this wave. And some pundits in your space just say, listen, this is a commodity, Jim, right? And Asia is just going to take over this entire market. At your investor day, right, you talked about deep customer relationships,
yeah.
right? Why do customers keep coming back and buying more?
Yeah, it's a great question. And it comes down to two things, right? Number one, it's our technology. So the breadth and depth of our photonics technology. And then number two, it's about being able to deliver that, right? It's one thing to innovate on technology. It's an entirely separate thing to be able to scale, to deliver at scale, high volume, high levels of quality. And when you look at Coherent within the photonics world, Coherent is really the only company that's got the breadth and depth of technology combined with the manufacturing scale. And you really have to have both of those with the
Yeah.
customers. And so, on the first one, on the breadth and depth of technology, if you look at, for instance, we build the transceivers that go into data center optical networking. Just one example, the transceiver is what converts the electrical signal to optical and vice versa. And in that transceiver, we don't just assemble and test the final product. We build all the key photonic ingredients that go into that, right? We design all of those photonic ingredients. That means all the different types of lasers, whether it's indium phosphide or gallium arsenide, right? The photodetectors that are used at the other end of the wire from the laser, all of the key materials, isolators, optics that go into that transceiver. So we've got the broadest and deepest portfolio of technology. And as you know, Pat, that's probably number one most important thing for customers as they partner over a multi-generational basis is what is the portfolio and innovation around technology that you can bring to us. But number two, the second part of the discussion is, okay, so you have the right technology solution. Can you deliver that? And
Yeah.
that's where we've got the other part of the key customer care about, which is, we're able to deliver, complex photonic technologies at scale. So materials, devices, subsystems, even full systems and software, we're able
Yeah.
to deliver high volume at scale. So that combination is critically important to our customers.
Yeah, I'm always fascinated when I look at the evolution of industries. They go through different cycles of aggregation and disaggregation. And in your space, aggregation is the name of the game. One throat to choke, and also time to market. People could buy this thing from this place, this thing, and then find somebody to put it together. Maybe they can do it for one cycle, right? But try to do that for two. Try to do that for three. Oh, and by the way, try to have enough manufacturing capacity online to make that happen in various places around the world. So, it's interesting. As a recovering product guy, Jim, I look very closely at core value propositions, and it's working. And probably the tip of the spear, at least on the hyperscaler side, with is you actually had an optical switch that I believe you started shipping as of late. I think that's what you announced, and you're going all the way from making the tiniest components to actually shipping the optical switch and pretty much everything in between.
Yeah, actually, I'm glad you asked about the optical switch because that was one of the products when I first joined Coherent that I was like, wow, I can't believe this, because I didn't know about this product before I joined. And by the way, I just passed my 1 year anniversary just I think just a
Wow.
few days ago. But within the first week or two, I joined the company, somebody showed me this kind of prototype around the optical switch, and I said, "Oh my gosh, guys, we got to get this to market as fast as possible." Because what an optical switch does is if you think about the data transmission from one computing node to another computing node, the data transmission is done optically in the scale out domain. But if you want to switch from one place to the next, today it's done mostly with electrical switches, right? Well, if you replace that electrical switch with an optical switch, you can keep that data signal in the optical domain. You don't have to convert it to the electrical domain, and that has a tremendous performance and power efficiency benefit. And so, yeah, we've shortly after I started, we really ramped up investment in this product line and accelerated our time to market. And the team, I'm really proud of the team. Just within the last couple of weeks, they achieved first revenue on this product line. And we have a very, very differentiated solution. We inside our optical switch, so we're providing the whole switch and the software on top, but inside the key technology that allows the signal to switch is based on what's called digital liquid crystal technology. It's a non-mechanical technology. And the other solutions that are out there are based on MEMS, which is fundamentally a mechanical technology, and that has reliability issues. Our solution is non-mechanical digital liquid crystal, which is borrowed from our telecom business. It's actually been used in undersea applications in our telecom business for years. So it's field proven technology. So we brought this now into the data center, tremendous advantage in reliability and a bunch of other characteristics. So yeah, customers are really excited about it. I'm excited about it. And now we're shipping revenue, which always makes me happy.
Jim, I learned something new every day about the company. I did not know undersea cables. Yeah, you just don't want to send a sub down there to fix a MEMS based device, do you?
No, I mean obviously that we use undersea cable example because that is the highest level of reliability that you have to achieve, right? Is because nobody wants to take a submarine down
No, exactly. This is great. Hey, we're talking submarines here, folks. This is great. Yet another innovation for Coherent. No, hey, let's dive in. So we talked a little bit around the data center transceiver. Essentially, everybody out there, it's the device that you plug into the switch that makes that optical connection. We talked about what are other parts of the AI value chain, other end markets that you participate in.
Yeah, good. Okay, good question. I would say a couple, right? So if we move beyond the data center, first example I'd give you is, as you know, these a lot of these workloads are so huge that they're starting to span multiple data centers, right? Or the
Yes.
data centers are constrained by the amount of just physical space or power that they can get into the data center, and so we're seeing these workloads, span multiple data centers where they're running across these multiple data centers. And what if you're going to run it across multiple data centers, what's key is that you have to have very high speed connections between those data centers and very, very wide high bandwidth pipes. So what that means is you need optical networking, you need very high bandwidth, high speed optical networking links. So what we're also seeing is a big increase in demand of these data center interconnect DCI transceivers, for instance, that we build that enable that high-speed networking between data centers. And so we're seeing tremendous growth there. And here again, we have great technology here because for years we've been providing key optical technology into telecom applications. And this is kind of like a telecom application.
Yeah.
This is telecom grade technology used for the connections between data centers. So that's one that we're really excited about. The other one that you might not think about that's maybe not as obvious is, AI data centers, the demand for AI, that's really driving the entire semiconductor technology transitions, right? So it's driving the semiconductor nodes from 3 nanometer to 2 nanometer and beyond. So it's driving the most advanced semiconductor technology. And what enables that is the wafer fabrication equipment, the semicap equipment. And if you look inside that equipment, a lot of that equipment relies on photonics, and that's where Coherent comes in. So another big area that we support AI data centers is in the photonics, lasers, optics that go into semicap equipment. When I started my career, we were on I think it was the quarter micron technology node. Pat, when you started, what were you guys like 100 micron or?
I think it was 250.
That was
Yeah.
I was kidding. That was
No, no, no,
so
no. It was, yeah, it was
when I was
250. Yeah.
I was on quarter micron when I started my career, and on the quarter micron node, we maybe had two or three optical inspection steps. That's now grown to when you look at 3 nanometer going to 2 nanometer. That's grown to almost 100 optical inspection steps, and that means photonics. So the amount of photonics, lasers, optics has grown over the years, and the complexity of those photonics has grown, which drives the amount of content. So that's another key area where Coherent supports the AI, especially AI data centers, is in the complex semi-cap equipment that drives the advanced technology nodes.
That is so cool, Jim. It really is. Freaking laser beams.
Yeah,
By the way, the hybrid multi-cloud is just starting and connecting data centers. And people laughed at me 10 years ago when I talked about having an application where the compute is in one data center and the data is in another data center.
yeah,
And
yeah,
what this does, it makes it a reality. And it's like, well, why would I want to do this?
yeah,
Well, let's say I wanted to have an application in the public cloud and then the private cloud or on premises and be able to span those. So that's even regardless of AI. And now, even though the Chinese did this first, we have U.S. companies, even like Meta, who are spanning models across data centers.
yeah,
Okay, and a high speed interconnect is the only way you can do that and make that happen. And then when you get into these reasoning models, when it comes to inference, right, this is not
yeah,
just about training.
yeah.
And you need a planar, a very large set of planar memory to go across. For reasoning models, I believe that we will see those spanning multiple data centers as well.
Yeah, and just as you said, look, that can only happen if we have super high bandwidth, super fast connections between those data centers, and that means optical networking, and that means driving the most advanced speed and the widest bandwidth optical
I
connections. That's
mean,
why,
you can't do this with copper.
yeah,
Okay.
well,
I
sure.
mean, that's just, and they, I don't even think anybody's connecting data centers with copper anymore.
No,
Um,
this is all optical, right?
yeah. Yeah.
This
It's
is
just,
telecom grade, super high speed, high bandwidth
yeah.
connections.
We need a new industry terminology, right? We have scale up networking, scale out networking, and I don't know, scale out networking.
Scale plus.
Is
Yeah.
that what it is?
I
Okay.
no, I just made that up. We should come up with a
No,
better.
we coined it here. Let's plant that flag, Jim, and move that forward as the standard. So Jim, um, the innovation engine. I remember talking to you the first time you came in. I was like, Jim, first of all, embarrassed. I don't know who Coherent is. Why would you join them? What are they doing? And I think it was I don't know, a month or so in. It's a Pat. Like I look under the hood at all of the innovations, all of the technology, and all of the possibility here. I also recognize that when I look at what your EPS goals were, I map that against your financial goals. It's like, okay, Jim, how are you going to keep the innovation engine chugging along?
Yeah, that's a great question. So, I'm an engineer, so I love innovation, right? So, certainly comes from a place of love, right? On innovation, I think, in my experience, there's really two things that you need to drive an effective innovation engine, right? Number one is there is a culture around innovation. You
Yeah.
have to have a culture. It's interesting, and I think companies that don't have a strong innovation culture, it's really hard to build an innovation culture. The great thing about Coherent is when I came in is that's probably our strongest cultural attribute as
Yeah.
a company is this is an amazingly innovative company. I think it's the most innovative company I've ever worked for. And I've worked for a number of
Wow. No,
extremely
that's big. I mean, you were Broadcom, AMD, right? Lattice. Yeah.
and we were talking about optical switches. We innovate at the system and software level. But what's really cool about Coherent is we innovate all the way down through the technology stack. We innovate at the device level, all the way down to the material science, the fundamental physical level for photonics, right? So there's this really strong culture of innovation, and I certainly want to continue to nurture that. And there's a number of things that we're doing internally to make sure that we continue to nurture that culture. Actually, next week, we're going to have an innovation summit within the company where we bring together all of the key technologists across the company here to the Bay Area and have a summit and talk about how do we drive better, faster innovation for the company. So we're really excited about that. That's one example. So that's one thing. I think it's about building a culture of innovation. But then I think the second piece is, and this is kind of where what you mentioned around the EPS and profitability is, look, it's about investment too. We've got to invest for innovation. You've got to place the right investment. But I also think you got to be careful, right? This is where I'm a big believer in customer driven, market focused innovation, where let's innovate, but let's innovate for the benefit of our customers, for the benefit of the market, right? For the benefit of the industry. Let's know that as we innovate, that customers are going to see real genuine benefit from that, and that the company will see a return, a good return over time on that, right? A good return on that investment. And so I think the second piece about it is making sure that those innovation dollars, those investment dollars, are directed at the right big areas of innovation that we know are going to drive a great return for the company over the long term. And so that's certainly something I've been focused on over the past year, is making sure that we've got those dollars invested in the right long-term innovation engines.
Yeah, so it's not about technology for technology's sake. It's really innovation for customers' sake.
You got it. Yeah.
Hard to do, particularly you have to make bets and guess on where the industry is going 3 to 5 years. I mean, sometimes it's easy. It's like, hey, faster, cheaper, and more reliable. Okay, that's where we're going. But to be able to intersect that with industry standards and new technology, and what I always like to talk about is the art of the possible. Right, your customers will never tell you what they need, and certainly if they do, it's going to be too late if you don't already have that, and you have to kind of transpose yourself 3 to 5 years from now to see where this goes. And by the way, I did a few projects like that before.
I bet.
And I really like it. And you get the brainiacs in the room from a technological standpoint, and then the people who really have a decent idea of even future casting out there. It's a lot of fun.
Absolutely. And this is exactly one of the themes of, I mentioned we're going to do an innovation summit internally next week.
Okay. Yeah.
This is exactly one of the themes is, hey, let's look beyond the horizon, right? Let's make sure that we're thinking about what's beyond the horizon and what innovation we can drive way ahead of what our customers have even thought about, right? This is one of the key themes that we'll talk about internally next week. And then let's make sure we invest for that as well. And then, what I love about Coherent is the deep technology innovation that we do at such a fundamental physical layer. I think that really helps us to be able to understand the art possible. When you understand the fundamental device physics behind photonics, right, the material science, then you're able to understand what truly is the art of the possible, and then drive to that.
Hey, Jim, I really appreciate the time. Our audience loves hearing what is Jim Anderson up to. What is the big deal with photons? And hopefully everybody understands why those are so important to AI today and in the future. So I appreciate that.
Yeah, thanks, Pat. Thanks for giving me a chance to tell you about why we love photons so much. So
That's great.
Thanks for the time.
So everybody out there, thanks for joining this cloud infrastructure spotlight at the 6.5 Summit. We're in our 6th year, and we just keep going here, and it keeps getting better. Hopefully, yes, that's what you told us. So, hey, connect with us on social media. Tune into more conversations we're having at our website, 65media.com. More insights, not as in more insights, but more insights coming up soon. Take care.